Good morning, everyone, and welcome. Today, we're diving into a comprehensive overview of blood spatter analysis in forensic science. We'll explore everything from its historical foundations and the underlying physics principles to real case studies, the challenges faced by experts, and the latest technological innovations shaping this fascinating field. I'm excited to take you through this journey and shed light on how blood spatter analysis plays a crucial role in solving crimes. Blood spatter analysis is a specialized area within forensic science that focuses on studying bloodstains, looking closely at their shapes, where they're located, and how they're distributed. By examining these patterns, we can piece together what happened during a crime. This analysis plays a vital role in helping investigators make sense of the events that caused the bloodshed. One of the key benefits is that it can help identify the type of weapon involved. Additionally, by analyzing the bloodstains, we can determine the direction and the force behind the impact that created them. All of this information contributes to reconstructing the sequence of events at the scene, which is crucial for verifying witness statements and either implicating or excluding suspects based on solid physical evidence. Let's look at the early history and development of bloodstain pattern analysis. Back in 1895, Eduard Petrowski laid the groundwork by studying how blood drops fall from different heights, which was a key initial step. Then, in 1955, Dr. Victor Baltazar and M. Lambert expanded on this by describing the basic principles for interpreting these patterns, giving investigators a systematic way to analyze them. The term bloodstain pattern analysis itself was introduced in 1971 by Herbert McDonald, who also contributed to improving investigative methods. Over the years, the field has grown significantly, moving from basic observations to using strict scientific protocols and advanced technology to increase accuracy and reliability in investigations. When we look at blood spatter, several physical forces come into play. First, gravity plays a crucial role by pulling the droplets downward, guiding their trajectory as they fall. Next, the velocity of the blood influences both the size and distribution of the droplets. For example, higher velocity impacts produce finer, mist-like patterns, whereas lower velocity results in larger drops. The angle at which droplets hit a surface also affects the shape of the stains. By analyzing the elongation and form, we can determine the direction from which the blood traveled. Ultimately, it's the interaction of gravity, velocity, and impact angle that creates unique patterns, helping investigators reconstruct the events, including the positions of the victim and assailant during the incident. Now, let's talk about the three main categories of blood spatters. First, we have passive spatters. These occur simply due to gravity, like when blood drips or flows naturally without any additional force. You can think of a drop falling from a wound or blood slowly flowing down a surface. Next are transfer spatters. These happen when a bloodied object comes into contact with another surface, leaving behind smears or wipes. For example, if someone touches a bloody knife to a wall, that contact creates a transfer pattern. Finally, we have projected spatters. These are caused when blood is forced through the air by an external force, such as an impact or pressure. This includes blood from gunshots, blunt force trauma, or arterial spurts that push blood out with significant velocity. Understanding these categories helps us interpret the events that cause the bloodshed and reconstruct the scene accurately. Here, we have three key analytical techniques used to enhance accuracy in crime scene investigations. First is the grid method, which involves overlaying a measurement grid on the surface being examined. This allows for precise documentation of evidence locations. Next is the stringing technique, where strings are used to trace trajectories, helping us determine points of origin, such as the path of a bullet or blood spatter. Finally, we have software applications, digital tools that calculate angles and trajectories and can reconstruct detailed 3D scenes. Together, these methods complement each other, providing a comprehensive and accurate understanding of the crime scene. Blood spatter analysis plays a crucial role in crime scene investigations by allowing us to reconstruct violent events with greater accuracy. By examining the patterns and distribution of blood, we can piece together the sequence and nature of what happened during the incident. Additionally, this analysis helps establish the relative positions and movement of those involved, which can be vital in understanding how the crime unfolded. One of the key benefits is its ability to either support or challenge eyewitness accounts and suspect statements, providing an important check against inconsistencies or false information. Another important aspect is its capability to differentiate between accidental injuries and those inflicted intentionally, which can influence both the investigation and the legal outcome. Overall, blood spatter evidence offers objective, scientific insights that not only guide investigators, but also play a critical role in judicial proceedings. Let's look at some real world case studies to understand the impact of blood spatter analysis. First, the Sam Shepard case from 1954. Initially, the interpretation of the blood spatter supported a guilty verdict, but later reviews raised serious questions about how the evidence was handled, showing how crucial proper technique is. Moving on to the O.J. Simpson trial in the 1990s, blood pattern analysis played a vital role in evaluating the crime scene and presenting evidence in court. Today, modern forensic investigations use spatter evidence to reconstruct complex crime scenes with much greater reliability, helping to piece together what really happened. These examples highlight the significance of blood spatter analysis. Not only can it influence verdicts, but also underscores the importance of careful, meticulous methods in forensic work. When it comes to analyzing patterns, one major challenge is the subjectivity involved. Different analysts might interpret the same pattern in various ways, which can lead to inconsistencies. This highlights the importance of standardized methods. Environmental factors also play a significant role. Things like surface texture, humidity, or even movement can change how a stain looks, potentially complicating the analysis. Another hurdle is contamination and degradation. Over time, evidence can become compromised, making it harder to draw clear conclusions. Finally, the analysis is often subjected to intense legal scrutiny. To withstand this, analysts need to adhere to rigorous scientific standards and maintain thorough documentation. Being aware of these limitations is crucial for producing credible and reliable forensic findings. Recent technological advances have really transformed how we analyze bloodstain patterns. First, high-resolution digital imaging lets us see stains much more clearly, revealing details that were previously hard to detect. Then, computer-aided design and 3D modeling enable us to reconstruct crime scenes with remarkable accuracy, giving us a more complete understanding of how events unfolded. On top of that, new algorithms are being developed to standardize the interpretation process, which helps minimize human error and ensures more consistent results. Finally, advanced chemical and luminescent reagents have been introduced, making it possible to detect blood evidence that would otherwise remain invisible to the naked eye. These innovations collectively enhance both the precision and reliability of bloodstain pattern analysis. Blood spatter analysis is an essential tool in forensic science, combining scientific principles with practical investigation to uncover the truth behind violent events. One of its greatest strengths is the ability to reconstruct these events with clear spatial and temporal detail, helping us understand exactly what happened and when. Over time, this field has evolved significantly, moving from basic theories to the use of advanced, sophisticated technologies that enhance accuracy and reliability. Despite these advancements, there are still challenges that we must address, requiring ongoing improvements in methodology. As forensic science continues to progress, blood spatter analysis will remain a critical component in providing key evidence to support the pursuit of justice.